All right, this little video is just a quick how-to with regards to finding maximums and minimums and zeros of polynomial functions. This video is going to mainly focus on the steps in that graphing calculator and how to work with those characteristics and find them easily on that device. So for starters, you see our polynomial function that we're going to graph here. X to the fourth minus x cubed plus x minus 3. So when you turn your calculator on, the first thing you're going to want to do is hit the y equals button in the top left-hand corner. Make sure that your plots are all turned off. So all of those, as seen on the calculator currently, should be off, right? So if you arrow up to it and press enter, that's plot 1 is now turned on. To turn it off, just select enter. Okay, so type that function in, x to the fourth minus x to the third plus x minus 3. Okay, graph. If for some reason your graph is looking funny, for example, I'll just kind of make mine look out of whack here. So for example, maybe your graphing screen or your window is set to something that makes it hard to view the function. You know, this function, or at least the ones that I'm going to be asking you to demonstrate or practice in class, is going to fit on this nice grid that's provided, a negative 10 by 10 for both x and y. And so to quickly get your calculator there, if you choose zoom, and then number 6, which says zoom standard, this is going to automatically set your window to that negative 10 by 10. Okay, so we can see the x min and max have changed for us. Now, you could, of course, just hit the window button and change those manually, but zoom 6 is the fastest way to snap your window to that standard viewing angle. Okay, so this function, we're going to go ahead and graph here. We want to get it plotted onto the coordinate system. Now, I recommend finding your maximums and minimums first, because if we jump straight to the table, so second graph, we jump straight to that table. These points provided are only where the x is an integer, right? Or it's a whole number and its opposites, positives and negatives. That might not give us an accurate picture of what the graph looks like. So I recommend finding the maximums and minimums first. So let's take a look at that graph. Okay, maximums and minimums. This curve, and I might change this one for this video, just because I want a little bit more variation. So let me play with it and see. It's a little bit more exaggerated. There we go. I want this one instead. So I'll change this, and we're going to say minus 2x to the third instead. Okay. So the reason why I want to do that is because then we can practice finding those maximums and minimums a little bit nicer, right? We can see a little bit more variation in this quartic function. So maximums and minimums, right? And specifically relative maximums and minimums. Those are extrema, or extreme high and low values in the neighborhood. So when I look at this quartic function, I notice that there is one maximum, kind of at that top middle point in this W sort of shape, right? So there's the maximum. And then it has two relative minimums, one on the left and one on the right. So let's find those. I like to go left to right on my screen because then I don't have to move my cursor around a bunch of times. And so I'm going to find the minimum because that's the furthest left on the screen. So second trace, choose number 3, minimum. Okay, and then your calculator is going to ask you 3 questions: left bound, right bound, and guess. To help you place the cursor correctly, or maybe I should back up and say the calculator is asking you to select a point on the left side of the minimum, then on the right side, and then it's going to run the algorithm to find the minimum value between. And so Easiest way to find left bound is to start with your cursor approximately at the minimum point, like mine is currently. To find left bound, I'm going to hit the left arrow 2 to 3 times. Okay, you could do 4 times, you could do 5 times. It really truly doesn't matter, but 2 to 3 times is good enough. So I'm going to hit enter to select that left hand point. Okay, to find right bound, do the same thing. Put your cursor back on the approximate location for your minimum. Hit the right arrow 2 to 3 times. There I'm on the right hand side. I'm going to press enter. When your calculator says guess, you don't need to move anything, just press enter right away. So there I see my minimum value as negative 0.37 if I round. I'm going to record that over here in my nice little worksheet. So an x value of 0.37 and a y value of negative 3.25. I'm going to go ahead and graph that as well right now, just so that that piece of it is done. Kind of ishy numbers, right? So I'm going to place this as best I can on this little system. You do the same. So negative 3.7 and negative 3.5 is, 3.25 is approximately right here in that orange point. Okay. So we're going to do the same thing, but I'm going to find my next extreme value. So the next one I have is the maximum. So I'm going to go second trace, now maximum. Again, find your left bound and your right bound. So easiest way, put your cursor approximately at that maximum point, hit the left arrow 2 to 3 times, enter. Find right bound, hit the right arrow 2 to 3 times, enter, and enter for guess. My maximum is at 0.5 and negative 2.69 if I round. So I'll plot that point on my system as well. About there. Okay. One last point to find. Second trace, minimum this time, because that next extreme value is a low point or minimum point. So left bound, hit the left arrow 2 to 3 times, enter. Right arrow 2 to 3 times, enter. Enter for guess. So my final extreme value is at 1.37 and negative 3.25. 1.37 and approximately there. So it's nice, those orange and green points look to be reflections of each other, and that's true because of our patterns here in that quartic. Okay, so then the next thing I would do is I would graph, or I would plot out the remaining points that the table in my calculator gives. So second table, and I would plot as many of those points as I can, provided the coordinate system I've got here on my paper. So I can plot the point negative 1, 1, 0, negative 3, 1, negative 3, 2, negative 1. So I'm going to plot those 4 points quick and see if we can get a sketch of this graph. Negative 1, 1, 0, negative 3, 1, negative 3, and 2, negative 1. Okay, so I know that the orange point is the absolute minimum there, or I should say relative minimum there. It's going to bend back up, the maximum on that purple, minimum at the green, and back up. Okay, so we got a pretty accurate sketch. Okay, the only thing that I'm missing here that actually I might go back and fix is this idea of the zeros. So the zeros of a function are where the graph crosses the x-axis. To accurately find those, right, I can't just look here and assume that that is negative 1, 0. Can't assume that it crosses the x-axis at exactly 2, right? It might be pretty close to those values, but if we use the operations here in the calculator, we can find them more precisely. So to do that, second trace, number 2 for 0. Then, just like we did for maximums and minimums, Start with your cursor approximately where the graph is crossing the x-axis. To find left bound, hit the left arrow 2 to 3 times. Enter. Go back to approximately where that 0 is located. For right bound, hit the right arrow 2 to 3 times. Enter. For guess, press enter. So my first 0 was at negative 1.097, so we'll say negative 1.1. And I don't have a spot for that here, do I? So I'm going to put it down here at the bottom. So zeros, negative 1.1, and a y of 0, of course, right? A 0 is where the graph crosses the x-axis, and so that's going to be where the y value is 0. Okay, do the exact same thing to find the second 0. So second trace, number 2 for zeros. Put your cursor approximately where that 0 is located. Hit the left arrow 2 to 3 times. For left bound, enter. Go back to that approximate location. For right bound, hit right arrow 2 to 3 times. Enter. Enter for guess. So my second 0 is at 2.1 and 0. So I probably wouldn't change the sketch I have. Those points are pretty accurate. I probably couldn't graph it any better by hand over here. Okay, I'll quickly talk about domain, range, and behavior increasing and decreasing intervals. Probably won't explain too much. I'll just write down what they are. So the domain for this function, since it goes left and right forever, does not stop. This means that x can be anything. And you're going to find that that's going to be the case for any polynomial function because their behavior continues forever in both the left and right directions. So just remember, domain is the x values, think left to right on your graph. The range is going to be the y values, think bottom to top on your graph. It's the lowest and the highest. Well, the lowest possible y value is actually those minimum values. So we could look at the orange or the green. They actually have the same y value. So my range would start at negative 3.25 and goes up forever. So any y value bigger than that. Parentheses always go around the infinities. This negative 3.25 gets a square bracket because I know that x can be equal to. So that's what that square bracket means. It can be equal to negative 3.25 exactly. Okay, end behavior. As x approaches infinity, remember that's the right-hand side. The right-hand side of my graph is going towards positive infinity on the y-axis. X approaches negative infinity, that's going left on the graph. The left side is also pointing up. The y values are getting more positive, so positive infinity. For now, those increasing and decreasing intervals, I'm just asking you to color code. So I'll make the increasing interval yellow. Okay. Anywhere where there's a positive slope or it's increasing as you move to the right is where our increasing interval is. So there's the first one, and there's the second. And our decreasing interval I'll do with blue. That's going to be the other two regions. So that's all I'm asking you to do for the increasing and decreasing intervals at this point. For some bonus or extra credit, you can work on writing those intervals and just work with me in the classroom if you want to kind of learn a little bit more on how to do that. I will say those increasing and decreasing intervals, you're writing them based on the x values. So just a heads up on that. Okay, I hope this video was helpful and as a resource you can come back to continually if you're just needing to see somebody work with that graphing calculator. Keep up the hard work, you guys. Thank you for watching.